Scaling a business is usually a sign of health, but pushing for the absolute maximum output can actually cause a company to fail. If you ignore the underlying math, an obsession with growth eventually reaches a point where the operation simply tears itself apart. To see how this happens, we can look at a commercial wheat farm attempting to maximize its annual profits. The farm owner has to track two sets of numbers. First are the explicit costs, the literal cash flowing out for tractor fuel and seeds. Then there are the implicit costs, like the opportunity cost of the owner's time. If they weren't running this farm, they could be earning a salary elsewhere. That lost income is a real cost of doing business. Looking at the vast horizon of the fields, the owner decides to double down. The plan is to hire a continuous stream of manual workers to harvest as much grain as the land can possibly provide. Warning tone. This strategy assumes that the only limit to profit is the amount of wheat in the silo. In reality, the farm is about to hit a physical wall that the owner hasn't even considered. At first, the plan works. One worker produces 3 tons of wheat, but hiring 2 more people causes that total yield to multiply 8 times, reaching 24 tons. This early surge creates a false sense of security. The owner assumes that if 3 workers provide this much growth, 30 workers will deliver 10 times more. In this initial stage, the workers have plenty of room to move. They divide the labor efficiently, specializing in different parts of the field without ever getting in each other's way. But this efficiency is temporary. The farm is approaching its short-run capacity, and the next few hires are going to be far less productive. The farm is operating in the short run, meaning it has a fixed amount of land and machinery. While they can hire more workers, they can't instantly manufacture more soil or buy more tractors. This leads to the law of diminishing returns. Because the physical space is limited, adding more and more people eventually leads to crowding. Workers start waiting for their turn with the equipment, or literally bumping into each other while trying to work the same row. This total physical product graph shows when crowding becomes a crisis. At the 7th worker, the wheat harvested stops growing, plateauing at 42 tons. When the 8th worker is hired, output drops to 40 tons. The farm is now less productive. Adding more variable inputs, like workers, to a fixed amount of land eventually destroys the flow of work. At this stage, every new hire is actually dragging the operation down. This physical chaos has a direct financial cost. We measure this through marginal cost, the expense of producing exactly 1 more unit of wheat. As shown here, the marginal cost curve begins to climb aggressively. Because each new worker contributes less wheat to the pile while still drawing a full wage, the cost to harvest that next marginal ton of wheat skyrockets. To lower these costs, the farm must enter the long run with a massive investment, building this multi-story facility to increase their overall capacity. But since new facilities can't be built overnight, the owner is trapped with their current equipment and must deal with these rising costs immediately. When physical limits are ignored, the cost of producing every new item begins to swell, silently eating through the profit margins the owner was trying to grow. While costs are rising, the revenue the farm earns is also changing. This brings us to marginal revenue, the extra income earned from selling exactly 1 more ton of wheat. To sell a significantly larger volume of wheat, a business often has to lower its price to attract more buyers. This means that as the farm's output increases, the price it can command for each additional ton begins to slip. This downward sloping line represents that falling marginal revenue. The more the farm produces, the less income they generate from the very next unit sold. The business is now caught in a double squeeze. It is spending more money to harvest the next ton of wheat, but that ton is worth less than the one before it. Profit peaks exactly where falling marginal revenue equals rising marginal cost. In the green area to the left, revenue exceeds cost. Stopping here leaves money on the table. But producing in the red zone to the right is a loss, actively draining the total profit already earned. Sustainable growth requires finding the exact mathematical threshold where the cost of the next unit no longer pays for itself. In business, knowing when to stop is just as important as knowing how to start.